So forces and moments, we will be working on this part now. Let's begin with the moment. Moment, you are well aware of the fact. Force into perpendicular distance will give you the moments. Now we'll be solving some numericals on this forces and moment part. Let's begin with some of the numericals. Let's start. So first I'll take one numeric example with given with the figure given. Example is present. I am presenting this example with the given figure. If you observe this part, see TA at A, TC at C, and their distance is 4, 2, and 2 over here. C to B 2 here or in this part. Secondly, if you'll mention just mention this is 2, this is 2, this is 4. This is a perpendicular distance. Remember the geometrical part. Perpendicular distances we are considering here. So total 2 meters distance, that is our BC, and the mass of 30 kg. This I'm not writing, just I'm writing 30 over here. Remember this will be your kg over here. So 30 kg. And if you resolve vertically upwards, now this is the upward force. Just remember this is what we are having. This is a TA. There is a tension of the rope. TC is the tension at point C by the rope. And this is acting downward. This is the tension, or this is the force acting downward because of this AB. AB, it is the force acting downward. T and TC are the tensions in the acting and upward. So when we'll resolve it, what will be the part? As TA and TC are in same direction, we'll be adding them. And this 30 degree, this part, this part is in downward direction. If you observe, this is in a downward direction. So as a result, I'll take this, subtract this part, this force. Now, when we'll multiply 30 with your gravity G, that will be your force. Right now will be with the mass, that will be minus 30. So TA plus TC, adding the two tensions or two forces, minus the force in the opposite direction, that will be minus 30. So total solution TA plus TC minus 30 is equal to 0. This will be your first equation. Let's go for the second equation. Now, second equation, we'll consider the moment about A now. We are considering, moment about A. That will be 6 TC. 6, how am I getting T6? Can I analyze? Can you tell me? In this case, see 4, this 4 plus 2. So that is what the 6 part is. This 4 and this 2. I'm adding this. So moment across TC. The distance is 4 plus 2. That is 6. 6 times. The distance, perpendicular distance multiplied by the force. That is our moment. Minus 30. 30, that is the direct force now. 30 multiplied by 4. Now this is the 30 multiplied by 4. This will be our mass. So after that we have to multiply it with 9.8. Remember, right now I'm taking just directly 6 into TC. Now without considering 9.8, that will be by default. I will be multiplying with that afterwards. Right now 30 kg mass multiplied by 4. Now 4, if you'll observe, this is the distance over here. This is the distance 4, perpendicular distance from this point to point A. So now, and we will be having getting the second equation, 6 TC minus 13 to 4. Now one point we are noting, not no need to resolve horizontally since there is no horizontal forces. If you'll observe, there is no force. So they are in equilibrium. So no forces are there in right and left. So no horizontal resolution I am taking. It is just we are applying top and bottom forces, upward and downward force. Okay. So let's go for next part. Yeah. So now what is just mathematical part now? 13 to 4. So 30 TC. What will be the TC? Now just we are solving equation T. That will be 30 multiplied by 4. I am multiplying this with the gravity G. This is multiplying by gravity G. So that will become your force in newtons. Divide by 6. Just general algebraic form relation. According to algebra, now final answer will be getting 13 to 4 into 9.8. Approximately it is 196.2. It is nothing but it is 196. So the result what we are getting, that is 196.2 Newton. You can calculate anywhere on a calculator there, or regular with the regular question. Now next part was, let's go for the next step. What is the next step now? From 1 we have this equation. Well aware of this, we'll be getting this equation TA 30 minus TC, and from this just I'm converting this part. What is the part in this case? Converting this part, this 30 mass into multiplied by G, that is 9.8. So you'll be getting this part in a force, that is a force in Newton as usual. So minus 196.2, that is also in a Newton. So final answer 13 to 9.8 minus 196.2. Final answer will be 97.8 Newton. This is what the final result or final conclusion. So we got TA over here as 197.8 and TC 196.2. So two forces are result. We are getting four forces to be. Okay. Let's go for one more problem there. Now see, if you go with the reflection view, I'm taking intentionally. What do you mean? Force, force. So here, what is the part in this case? 20 Newton force is applied to the end of 0.4 meter lever. This is 60 degrees now. Okay, and this is the lever, and the force is applied in this way. You know that if we are while we're driving or the buttons or in the car also the gears, what we use this system. This is the basic system which is applicable. Now this is the moment arm D has a length. Now what will be the length of D? D will be 0.4. This is distance multiplied by sine 60. That will be 0.3464. Now how did I get this? How I'm getting this distance? See, I'm going with mathematical trigonometric pattern. See, I'm drawing over here. So the distance D, now this 60 degrees. What is sine 60 now? It will be sine 60 here. Sine 60 will be F applied to the end of 0.5 meter lever. So if this is the distance, what is if this is D and this is 0.4? Okay. So sine 60 will be equal to D upon 0.4. The opposite side multiply divide by the hypotenuse. So D will be equal to 0.4 into sine of 60. So that will be 0.3464. What is it? This 0.3464. Just you can take the calculation in this case now. 0.3464. That is the multiplication. What is this? This is just opposite upon hypotenuse. So if you go with this triangle. So momentum D, the distance, this is why I'm finding this D because I want this perpendicular distance. Getting idea? What is the concept over here? I want perpendicular distance because of this perpendicular distance, and we are finding this all these things. Going finding the resolving this into vector components using the trigonometry and getting the distance. So distance will be 0.4 into this one. This is sine 60. So now what is the force now? What do we want? State the force. What is the question? State force produced about point A. About this point O, what is the force is produced and state the direction of rotation, how it will move, what will be the direction of rotation. So next go, what is the momentum we got just force will be, now we know the definition here, force into perpendicular distance, that will be your moment and 20. So 20 multiplied by, I'm getting 20. The 20 Newton force is there, is applied. This is applied force, huh? This is applied force and the moment force. Don't get confused. Moment that find the magnitude of moment. We have to calculate magnitude of moment when force of 20 Newton is applied. This is the force Newton. This is equal to 20 Newtons. So that will be 20 into 0.3464. That is the distance, force into perpendicular distance. So final answer that will be 6.92 Newton meters, 6.92 Newton meters. So this is your final answer. Now where it will move? It will move clockwise or anti-clockwise. You see, this way or this way. Any guesses? So if you'll consider it is moving in that way, so it will be the force applied. So moment will be, I'm applying force. When force this is applied, moment will be in this side. Is how the force will be applied. Yeah, it force is in this way. It will be turning. This will be a turning effect. This will be a turning effect. So finally, it is going to move. How it is going to move? It is going to move clockwise. Getting idea? It will be moving in a clockwise direction. This way, this way. So clockwise moments. Yeah, the rotation will be your clockwise. This is what the final answer for the movement is there, and the direction rotational effect is it is moving clockwise, and 6.92 Newton meters will be the moment of force. Okay, thank you.